Bismillah. So I'm gonna talk about compliments. Not the type of compliments you wanna hear, but the type of compliments that you and I probably hate. But hopefully this is a simplified way to do it. So complements are the pro-inflammatory serum proteins. So they are proteins just hanging out in the serum with your red blood cells and white blood cells, and they are not activated. They are just there to complement the blood vessel and, give it regards and whatever. Okay, so you have your complements as pro-inflammatory proteins that will help the innate immunity, and probably, I have no idea, maybe the adaptive immunity as well. But what's the important things to remember? You have two things. So the activation pathway, and then your weird type of, pathway of activating each complement and what each complement does. Okay, so this gets activated. Okay, so all of these pathways activate to activate an enzyme. Your classical pathway, very classic, number one, complement one, comes in to an IgG. Okay, this is written wrong. So an IgG or an IgM that are bound to an antigen. So it comes here and tells them, okay, I want to bind to you because you are bound to an antigen. This is the classic pathway, very easy, very simple. Then you have your alternative pathway and your Manus pathway. This guy Manus just put his name just because he wanted. Okay, they are both related to a microbe. Okay, they are both related to a microbe. Your alternative pathway is a microbe making products and directly activating the complements. Okay, and then your Manus is basically the Manus binding lectin. Okay, Manus binding lectin, whatever you want to call it, and it binds to Manus. Okay, so again, we're going to the microbe. Manus is something on a microbe or a pathogen or whatever. It's just there on the microbe, all right? So what is the MBL, Manus binding lectin? Okay, Manus binding lectin is basically another protein in the serum that is made by the liver or whomever that it makes it. So you can remember it as something similar to how the complements are, which are just proteins in the serum. Okay, so it goes on the microbe. If the microbe doesn't make its products, it just tells it, okay, you stop here, I'm going to activate the complement system. Okay, so what happens with the activation of the complement system? Your activation starts always with your C3 convertase. C3 convertase, what does it do? It converts, as its name will say. Okay, so it converts C3 into C3A and C3B. Okay, your C3A and C3B are there for some jobs. Okay, we'll talk about C3 later, but C3B is the one that's going to continue the activation, and it has a mission. Okay, C3B is a guy who has a mission. Okay, so C3B, what does it do? It comes here and activates your C5 convertase and then just goes. Okay, so it goes here and does its job directly as an opsonin. An opsonin is basically a marker. So an opsonin is a mark for your microbes. And what I'd like to think about it is that it's a big kiss, as number 3 suggests, and as B suggests, it's big, and it's a kiss. Doesn't matter. So the microbe will get its last smooch. Okay? Last one. Okay? By this big complement. Okay? So it gets signed and marked. And who will see this? Your phagocyte. It needs to detect the microbe. How does it detect it? It detects it by this guy, the complement 3B. Okay? So it detects it and just eats it. That's your phagocyte. Okay, now that's the mission of C3b. Now after it converts, after it gives the activation of C5 convertase, which is another converter of C5, I mean. So C5 turns into your C5a and C5b. And your C5b is a lost friend, doesn't have anybody. Your C3b, we said already that it has its friend, which is, it kisses your microbe, and its friend is the phagocyte, which, you know, they help each other to actually get rid of that. You can think about them as the guy who comes in as the spy, and then you have your assassin, okay? Your assassin and your spy, whatever it does, you know. So then we have the C3A and C5A. These are called anaphylatoxins because they activate your mast cells, okay? If you've seen the video or whatever, anyway, they activate your mast cells, and mast cells can cause anaphylaxis. That's why they're called anaphylatoxins. Anaphylaxis is a very high, sensitivity reaction of the type 1, and it can cause death, as in with asthmatics and, people who get bit by a bee, stung by a bee, yeah. You don't get bitten by a bee. I don't know how that happens. Okay, this is a very strange thing in here. So your neutrophils get activated and get attracted by C5a, so A and A, attraction and activation. Or if you want to call attraction as, chemotaxis or whatever, it's your call. But A and A helps anyway. But then now your C5b is a lost friend, doesn't have anybody. So what does it do? We do not only have those complements, we have other complements, which are C6 to C9. So what does C5b do? It comes in and makes friends. And these friends are all called your membrane attack complex. And your membrane attack complex is a big, big bullet. Okay? It's a big bullet. What does it do to the microbe? It just perforates it. Okay? Perforates it, and there you go. Your microbe dies and becomes debris. And there you go. This is how I like to think about it. It's very simple. It's a little bit too strange, but it helps.